Alright folks, let's take a dive into the fascinating world of quantum mechanics. Quantum mechanics, at its core, is the branch of physics that deals with the behavior of particles at the atomic and subatomic levels. We're talking about electrons, protons, and photons here. These particles don't follow the traditional laws of physics that govern our everyday world. Let's start with the basics. One fundamental concept in quantum mechanics is wave-particle duality. This means that particles like electrons can exhibit both wave-like and particle-like properties depending on how we observe them. Imagine trying to look at a single particle and suddenly realizing it behaves like a wave. This dual nature was famously demonstrated in the double-slit experiment. When particles like electrons pass through two slits, they create an interference pattern on a screen, just like waves would. But if you try to observe which slit they go through, they act like particles, and the interference pattern disappears. Mind-boggling, right? Next up, we have the uncertainty principle, formulated by Werner Heisenberg. This principle states that it's impossible to simultaneously know the exact position and momentum of a particle. The more precisely you know one, the less precisely you can know the other. This isn't just a limitation of our measurement tools, it's a fundamental property of the quantum world. Another cornerstone of quantum mechanics is superposition. This concept allows particles to exist in multiple states at once until they are measured. Picture Schrödinger's famous thought experiment, a cat in a box that's both alive and dead until you open the box and observe it. While this sounds like pure science fiction, superposition is a real phenomenon at the quantum level. It's what makes quantum computing so powerful, as quantum bits or qubits can represent both 0 and 1 simultaneously, vastly increasing computational power compared to classical bits. Entanglement is another intriguing aspect of quantum mechanics. When two particles become entangled, their states are deeply interconnected no matter the distance between them. Change the state of one particle and the other instantly changes to match it, even if they're light years apart. Einstein famously referred to this as spooky action at a distance. This phenomenon is being harnessed for quantum cryptography, promising ultra-secure communication methods. Quantum mechanics isn't just theoretical, it has practical applications too. Technologies like MRI machines, semiconductors, and even lasers are grounded in principles of quantum mechanics. So there you have it, a brief yet comprehensive dive into the world of quantum mechanics. Remember, the quantum realm is as fascinating as it is perplexing, challenging our understanding of reality itself. Thanks for tuning in, and stay curious.